Welcome back. Today we're talking about the law of cosines, which is a way to sort of solve triangles. Now, like the law of sines, the law of cosines can be used to solve any triangle. It's a little bit more complicated than the law of sines though, so buckle your seatbelt, watch carefully, and we'll figure out how it works. You can use the law of cosines to solve a triangle if you know the measure of two sides and the included angle. Now, it's very important that you're doing the included angle. I'll show you what I mean. Here's a triangle, and here are the law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of a. Or b squared equals a squared plus c squared minus 2 times ac times the cosine of b. Or c squared equals a squared plus b squared minus 2ab times the cosine of c. Whew! That sounds awful, but it's not so confusing if you look for patterns. So let's look at this part. This is sort of the Pythagorean theorem. And we know that all the lowercase letters are sides. Now, if you go to the right just a little bit, you see all subtraction signs, scoot over just a little bit, and then all twos. Okay, now look at these two letters here. These letters represent the sides that sort of hug that included angle. And those are the same letters that we saw in that Pythagorean theorem look from before. So these two, BC, is the same BC at the beginning of the equation. This AC is the same AC. This AB is the same AB. Okay, now let's look at the ends of these equations. The capital letters are angles. And at the end of each of these equations, we're talking about the included angles. And if we look to the front of the equation, those included angles point back to their corresponding sides, or the sides opposite the angles. So in general, let's sum it up like this. We have a squared equals b squared plus c squared minus 2bc times the cosine of a. Okay, b and c, those are the sides that hug the included angles, and those are the same that are represented here. The end is the included angle, and the beginning is the side from the included angle. Now let's take this for a test run and see if we can make it work. Here we have a triangle. We've got two sides and an included angle. We need to find C. Okay, so let's use the equation that deals with C. So we'll have C squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 48. Now, where did all that come from? Well, remember, these two numbers here are the sides that hug the included angle. Cosine of 48 is the included angle, and we're looking for C, what's across from that. Now we'll start simplifying this equation. So 12 squared is 144. 10 squared is 100. We can add those together, and then we can multiply this back half. So we get 244 minus 160.58. So C squared equals 83.4. Then take the square root of both sides, and we get that C is approximately 9.13. Now let's try one where we need to find an angle. We're looking for angle A, so we can use the equation that deals with A. Our equation would be 7 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of A. So 5 and 8, those are the sides that hug the included angle. 7 is the side across from the included angle, which is A. So we've got 49 equals 25 plus 64 minus 80 times the cosine of A. We're going to add 25 and 64 together, and then you really have to make sure that 80 stays with cosine of A. Multiply those together. Be careful not to subtract it from the first two numbers. That's a common mistake. So 25 plus 64, we'll subtract that from both sides, and we get negative 40 equals negative 80 cosine A. Divide both sides by negative 80, so we know that cosine A equals 1/2. Now to find the measure of the angle, we need to take the inverse of 1/2. So cosine inverse 1/2 equals A, so we know that A is 60 degrees. Now, what if the triangles aren't labeled A, B, and C? Well, actually, that's okay. So we'll just pull up one of the equations right here. Now, what we have to do is just figure out what you have and plug that in. So for this one, we have two sides that hug the angle 89. Okay, so two sides that hug the angle. We have the included angle, so that's what we plug into our equation. And we're looking for A, which is what's across from the angle A, which in this case is called x on the triangle. So we've got x squared equals 14 squared plus 15 squared minus 2 times 14 times 15 times the cosine of 89. And we just have to simplify this equation one step at a time. So 14 squared plus 15 squared, that's 421. And then we subtract 420 times the cosine of 89, which is 0.017. So x squared equals 413.86. Take the square root of both sides, and x equals 20.3. Okay, let's do another one that's not labeled A, B, and C. We've got two sides and an included angle, which in this case is what we're looking for. So the sides that hug the angles, that's 14 and 10, and then the side across from the included angle, that's 9.6. So we put all that into our equation. And then again, it's just a matter of simplifying this equation one step at a time. 14 squared plus 10 squared, that's 296. And then 2 times 14 times 10 is 280 times the cosine of x. So somehow we have to get x by itself. So we'll subtract 296 from both sides, divide both sides by 280, and we find that the cosine of x equals 728. So we'll take the cosine inverse of 0.728, and that will give us that x equals 43 degrees. Yeah, there's a lot going on in these equations. But again, just figure out what you have. Which ones are the sides that hug the angle? What are you looking at? Plug in what you know, and then just very strategically simplify the equation. You can do it. Thanks for being here.